When you start thinking about absolute value, you think distance away, which is really simple. When we talked about absolute value of x equals 3, we could see that, well, of course, -3 and +3 were the same distance away from 0. When you start thinking about greater than, then the distance of that absolute value is bigger than that number. So if we look at the first one, absolute value of x is greater than 3, then that means all the numbers that are further away from 0 than 3. So obviously numbers larger than 3 are going to be farther away, right? But on the flip side of that, ones that are smaller than -3 will also be further away. Does everybody see that? So if I want the distance to be further away from the number, I actually create two statements. I create, well, that number, anything bigger is obviously further away, or anything smaller than the negation of that number is also further away. So this one inequality actually creates two options here. The same thing holds true when it is less than. So I want all the numbers that are closer to 0 than 3. Well, obviously any number smaller than 3 is going to be closer to 0. But on the flip side of that, when I get to the negation, I actually need to be bigger than -3. Because if I get smaller than -3, they're further away, not closer. All right? And so this inequality creates these. This is an and when you think about combined inequalities. The x must be in between -3 and +3 to be smaller distance away from +3. And so anytime you have an absolute value inequality, you actually create two inequalities depending on what it is. If it's greater than, it creates an or inequality. If it's less than, it creates an and inequality. All right? And when you start solving these, you actually set them up as two inequalities and solve, just like when you had an absolute value equation. You set it up as two equations and solve. So if we look at these two examples here, example 1, they want us just to graph this. Well, if x is greater than or equal to 2, it also has to be less than or equal to -2. So I took what was inside and I set it up exactly how it was given to me. And then I took what was inside, I flipped my greater than less than, and I negated the outside. All right, and that's how I got this particular graph. So if this is an or, I would do a closed circle here on the 2 and everything bigger. A closed circle on the -2 and everything smaller. All right, the same holds true if you have some type of properties inside: addition, subtraction, multiplication, division. I'm going to take what is inside, 2x minus 7. I'm going to make it look exactly like this, less than 4. All right, because this is less than, this creates an and. I'm going to take what is inside, and I'm going to flip that less than and make it greater than. And I'm going to change the +4 to -4. All right, so you still create two. You create one exactly the way it's given, and then you take the inside, you flip your greater than less than, and you negate the outside. And then you're just going to solve the way we would always solve. We're going to add our 7. We get 2x is less than 11. Divide by 2. X is less than 11 halves. Add your 7. You get 2x is greater than 3. X is greater than 3 halves. And this is an and. So you can take the smaller one, which is 3 halves, less than x, less than 11 halves. So you can write it that way as well, or you can write an and in between, and those two can be your answers. Keep in mind, it is only where they cross over. This is a less than, not a less than or equal to. So I'm going to go to 11 halves, which is at 5.5, right? Open circle. I'm going to go 3 halves, which is 1.5, open circle. And I'm going to graph everything in between it. All right. So if you get your absolute value by itself and it's greater than, it's going to be an or. Absolute value by itself less than, it's going to be an and. All right. So you're looking for compound inequalities here. You're going to create two of them. All right. So I want you to try a couple of these. All right, so they've given us the rules here. Absolute value inequality theorem. If C is greater than or equal to 0, meaning the number that you have less than or greater than 2. The absolute value, if it's less than C, is a conjunction. All right, less than creates the and. So you can literally set it up with what's inside with the less than, and then to the other side, put a greater than and the negation. And you can just set it up like that. If it is greater than, you will have a disjunction. You will have an or. You have to get it by itself first, okay? Just like when we did equations, you have to get it by itself first. So if you look at this next example here, you'll notice that this is not by itself. So before I even set up 2, I'm going to add this 11 over, all right? And so now I have a 15 out here. Now I'm going to set up 2. This one is greater than, so this is going to be an or. So I'm going to say the inside then, negative 4x plus 9 is greater than or equal to 15. Or the inside, negative 4x plus 9, is less than or equal to negative 15. Flip your greater than, less than, negate your outside. All right, and then once you do that, you're just going to solve. Subtract 9 over, you're going to get negative 4x is greater than or equal to 6. Here's a situation where I am dividing by a negative. So I will get x, and this will flip because I divided by a negative, is less than or equal to, and reduce negative 3/2. Same thing happens over here. I subtract my 9. I get negative 4x is less than or equal to negative 24. And I have divided again by a negative. So I do need to flip this. X is greater than or equal to positive 6. And this is an or. So those would be my 2 answers. And I would graph those. Closed circle, larger than your 6. Closed circle, smaller than your negative 1.5. All right? And so you do have to follow the same rules as your inequalities. So is this by itself?
Yes.
Yes, it is a less than. So am I going to have an and or an or?
Or.
And. All right, so this is going to be 2x plus 3 is less than or equal to 0, right? And it's also going to be what? Greater than or equal to 0. So, and it's also is greater than or equal to 0 because 0 does not have an opposite, correct?
Yes.
So we're going to subtract my 3, right? 2x is less than or equal to negative 3. Divide by 2, x is less than or equal to negative 3/2. So far, so good. All right. Subtract my 3 on the other side. All right. We have 2x is greater than or equal to negative 3. Divide by 2, x is greater than or equal to negative 3/2, right? So far, so good? No?
Should we positive 3?
Now, this is an and. All right? And, right? We said this was an and problem. So if I were to do a number line here for this guy, and I'll move this one down. All right. I have 2 answers here. The first one says that I am going to be closed circle on negative 1.5, right? Which is right here. Closed circle and everything smaller, right? The next one says closed circle and everything larger. It's only where they cross over. So this one only has one answer. What is it? Yeah, so x equals negative 3/2. X equals negative 3/2, right? That's your only answer because this is an and problem and it's where they cross over. So when it equals 0 and it's and, it's actually going to be where it equals 0. So you could have set up in a problem that it equals that, and that's just your answer for you. All right, for this one, this is already by itself, right? It is a greater than, and or. for greater than is or. So for this one, you're going to do just like you would greater than or equal to exactly what it gave you. And then you would say or 5x minus 8, flip that to a less than, negate the entire group. So you're going to have to distribute that negative. So go ahead and try this one on your own. We're going to do this one together. So here you have 3x minus 11 is less than or equal to 2x minus 9. It's a less than, so is this and or? It's and. So I'm going to take my inside. And I'm going to say 3x minus 11 is less than or equal to 2x minus 9. And 3x minus 11 is greater than or equal to negative 2x minus 9. So I've set up two problems here, okay? I'm going to solve just like I would. Subtract my 2x over. I get an x over here. Then I'm going to move the 11 to the other side. And I get x is less than or equal to 2 for that one. Solve on the other one means I need to distribute first. So I'm going to distribute here. 3x minus 11 is greater than or equal to negative 2x plus 9. All right. And then I'm going to move my x over. Get a 5x here. Move my 11 over again. Greater than or equal to 20. And then I am going to divide by 5. So I get x is greater than or equal to 4. And I said this was an and problem. All right. So if I were to put a number line out here to check this, I would say, well, this one right here says less than or equal to 2. So I'm going to close circle on 2, everything's smaller. This one says greater than or equal to 4, close circle there, and everything larger. And means where they cross over. Where do those two lines cross? They don't. So my answer is actually this. I don't even have to plug it back in. I get no solution there because they don't cross anywhere. And it's an and problem. Okay? And so if you have created an and you don't cross over, you have no solution. All right, so you will have to graph these for me. So I'm going to actually force you to look at that picture, okay? But you do need to recognize whether it's an and or an or, because if this had been an or problem, this answer would have been fine, right? And you would have had both of those as your answers. But because it was an and problem, you actually had no solution as your answer. And so you do want to go through these and make sure that you understand whether it's an and or. So you want to make a note of that and study that so that you remember when you're doing these if it's and or, because it will make a difference in your answer.